Hey guys, welcome back to another TechTrek episode. And today I'm going to be showing you guys a code in order to convert your Ethereum private key into a 12-word mnemonic phrase. So let's get started. So currently you can see I have Visual Studio Code open up, and we're going to write this code in Python. Beginning with the first line, we're going to define our library, which is biputils. And we want to import the BIP39 mnemonic generator from that library. In the following line, we're going to define our function as private key to mnemonic private key hex. Okay, so this function is going to take the hexadecimal Ethereum private key as an input and return it as a 12-word mnemonic phrase. Sometimes when you export the private key, it begins with 0x. We want to make sure that we catch that and remove it if possible. So the next line is going to check for 0x prefix is present if private key hex starts with hex. We want the private key hex to start from 2 characters to the right. Now, in the following line, we want to check if the private key hex is valid. It should be 64 hex characters, which equals to 256 bits. So to do that, we start with if the length of the private key hex is not 64 or does not contain the following characters. So 1, 2, 3, 4, 5, 6, 7, 8. For a character in the private key. Raised value error, invalid Ethereum private key format. Now, once we get past that and make sure that everything is okay, we want to convert the hex private key to bytes. And in order to do that, we're going to enter the following: private key equal bytes from hex private key hex. Now we want to ensure we use only 128 bits, which is 16 bytes, of entropy for a 12-word mnemonic phrase. And to do that, we do entropy bytes equals private key hex bytes 16. Using the first 128 bits of the private key. Now next we want to create an instance of the BIP39 mnemonic generator. Okay. Now we need to generate a mnemonic phrase from the private key bytes using the BIP39 standard. To do that, we're going to define the mnemonic equals the mnemonic generator from entropy, the entropy bytes. Then we return the value. Okay. Now to use this, we're going to define the private key hex. We're going to get that in a moment. Then the mnemonic phrase is going to call the function on the private key hex. Then we're going to print the result. So let's save it and test it out. Just going to save it on my desktop as PK test. Now let's get our private key hex. Let's use MetaMask. Now to get our private key, click on here, and account details, show private key, enter our password. And we now have our private key. We're going to take this, put this into our project, save it, and let's test it out. Now we're going to open up Terminal, change directory to our desktop where we saved it, Python pktest.py. Would you look at that? We have our 12-word mnemonic phrase, but we have to make sure it works. So let's copy this phrase. Let's use our Trust Wallet. I'm going to import. Set a password, click next. Make sure that the drop-down says I have a 12-word secret phrase. Let's paste it in. Click next. No thanks. All right, looks like we're in.